So the key idea with proof by contradiction is that we're asked to prove something. So we actually decide to believe and state the complete opposite, and therefore try and prove that opposite is true. And in the process of trying to prove that the opposite is true, we actually come across some problem. It might be in terms of a logical statement, or it might be just a statement that's just plainly false. We come across some problem that basically is ridiculous, absurd, and cannot be true. And if that can't be true, then the original decision of deciding the opposite being true is just absurd itself. And therefore, because I've proven the opposite cannot be the case, then it must be the case, therefore, that the original statement that I was being asked to prove must therefore be true. So we're looking for the opposite. We find the opposite doesn't work, therefore the original statement must be true. So I'm going to go through a couple of examples to demonstrate the process. So here's an equation that I'm being asked to prove that there is no solution for. So i.e. there's no value of x that would fit this equation. No real solution. So I'm going to prove this, i.e. that there is no solution to this equation. I'm going to prove this by contradiction. So the contradiction is I'm going to suppose that there is a solution, that there is a value. Let's call it p. I don't know what it is, but let's call it p. So let's just say that p is a number that will work, that will give us this equation as stated. So all I've done is substitute a p instead of the x. So we're assuming that this statement is true, okay, for some value p. Well, if that's the case, then I can manipulate this as a statement. So let's just multiply both sides by p plus 3. Let's open up brackets and tidy up a little bit here. I get p squared plus 3p on the right hand side. And now if I were to do a little bit of cancelling, so if I was to subtract p squared and I was to subtract 3p, I'm left with 1 on the left hand side and just nothing, 0 on the right hand side. Now this statement 1 equals 0, okay, is just plainly not the case. It's just absurd, it's incorrect, okay, it's impossible. And if that statement is impossible, then we can say that no solution exists, okay, does not exist, and therefore the original statement, okay, is true, okay, as in that there is no solution. Okay, so no solution to equation. The key idea is that I had a statement, I decided the complete opposite was the case, I decided to try and prove the complete opposite, I came up with something absurd, and therefore disproved my opposite statement, and therefore I am therefore proving the original statement is true. We'll go through another example. This one's sort of a geometrical one. So let's have any triangle, and we're stating that there is no more than one right angle. So there's either one right angle or no right angles. There's certainly not two or more. That's the statement. So how do we prove that? So let's do the complete opposite. So with a proof by contradiction, we need to come up with a statement that is directly opposite to what we're trying to prove. So here we're going to say that there are two angles that are right angles. So I've randomly chosen angle A and angle B as a visualization there for you if you didn't realize what a triangle looked like. And that is the statement we're going to say. We're going to try and we're going to state that the opposite of what I want. So angle A and angle B are both right angles, more than one. Okay, and then we're going to use logical almond. So we know that that the three angles in a triangle, so angle A and angle B and angle C, equal to 180 degrees. That's a given known theorem. So therefore, if A and B are both 90 degrees in size, then 90 plus 90 plus angle C equal 180 degrees. But if I take away 180 from both sides, we therefore have a situation where angle C is equal to 0. But this is absurd, okay? This is not possible, okay? It's impossible because all three angles have to be greater than 0, okay? Since three angles must each be greater than 0, okay? Or not the three angles, since each angle, okay, I suppose is the best way of describing it. Since each angle must be greater than 0, okay, for it to be a triangle, we have a situation where this is absurd, okay? And therefore we can say that any triangle can have no more than one right angle. I suppose I should actually, I feel as though I need to put something else in here. I suppose I should say that angle A and angle B cannot both be right angles. So again, proof by contradiction, come up with the opposite case, try and prove it, come up with some nonsense, and because of that nonsense, because of that impossibility, therefore your assumption is wrong, and because your assumption is wrong, therefore the original statement must be correct.